First of all, you should know that algebra is all about using letters and symbols to represent numbers. Some people see it as a puzzle that has to do with letters and numbers, whereby you have to look for the value of the letters or the symbols being used. Now, to begin, let us analyze what we call the function machine. Function machine. Now, a function machine is simply a box of information that shows mathematical operations that happen with numbers to generate an output. So what it simply involves are three stages. And for us to work with this three stage, we'll be looking at what we call the one-step function machine, because that will show us exactly the three stages we talk about. The one-step function machine. This is the easiest level of the function machine you learn first before going forward. After this one-step function machine, we'll go to learn the two-step function machine. But for now, let us begin with this. The one-step function machine deals with the input stage, the operation stage, or you call it the process stage. And then finally, we have the output stage. Now, I am going to take time to explain each of them to you. Now, what happens is when you make an input, let's say on your calculator, the input goes through a process or an operation stage to give you an answer. The answer is called the output. Let me show you another example. Take, for example, the operation you want to work with is you are multiplying by 3. Operation multiplying by 3. In this big box of information, this big box should represent your processor in the calculator or in the computer system you have. Alright, it simply means that if I'm working with the number 5 as my input, once I input the number 5, it is going to operate on it by multiplying it by 3 to yield an output of 15. Did you understand that? You notice what is connecting 5 and 15. It's operation right here at the middle, which exists at the process. What if I bring in the number 6? What will happen to the number 6? Obviously, you will see that 6 multiplied 3 is going to give me the number 18. So, this is what a function machine looks like. For your level, you'll be expected to find one of the missing values, maybe at the output stage, the operation stage, or the input stage. For instance, let's look at some of these examples, and I will show you the trick of solving similar problems in your subsequent tests. Okay, this is the first one we have just done. Now let's take, for instance, you are asked to find an operation that must have existed to make a number like 3 become the number 5. And then the same operation is what made the number 1 to become the number 3. Now, obviously, you would be thinking about it, and I believe you have found the answer. See, how did 3 change to 5? 3 must have changed to 5 when we added 2 to it. But don't just write 2, test the next one to see if it's true. How did 1 change to 3? 1 can only change to 3 when you add the same 2 to it. Did you see that? We have been able to fill in the process stage, being that we know the input and the output of what we are solving. Now let us try a situation where we are given the process stage and the output. Let's find the input. Now what is going to happen if a particular number goes through a process of minus 11 and then the output yields 12? And also, what if the output yielded first the number 6, and what if the output yielded negative 3? Now your question is, what would have been the inputs that led to these outputs? Now, one simple thing that you need to do when you are given this kind of problem is to use the reverse operations which you learned earlier in your area levels. The reverse operation is, if an addition was involved in the process, change it to subtraction when you are going from output to input. Now that this is subtraction, we are going to change it to addition mentally when we are reversing. That is what will yield us the input. Now to do that, since A number we had, 11, was subtracted from it to give us the number 6, the output 6. All I will need to do is to add 11 to 6. And if I add 11 to 6, that gives me 17. It means that for this first number, 17 was the input. For the second number, 12 add 11 gives us 23. So 23 was the input. And for the third number, which is negative 3 add 11 is simply saying 11 minus 3. And 11 minus 3 gives us the number 8. So the number 8 was the input. Did you see how easy that can be? If this was a multiplication sign, I would simply divide and get my answers. If this was an addition sign, I would simply subtract it from my output to get the input. And if it was a subtraction sign, just as it is, I would have to add like I did. So all you need to do is to use the reverse operation of the operation given to get back your input. But if you already had your input and you have the operation, all you would need to do is to go straight. Now we have demonstrated with these examples how to solve problems using the simple step function machine or the one-step function machine. The next thing we are going to do is let's try solving a word problem using the same method. So get ready for the word problem. I have a word problem that wants us to fill in a table. Let's read it. It says, for a science task, students need to find as many crickets as possible and record the total number of legs they have. The table below shows Sam's findings. Help Sam to complete his table. Also write a rule for Sam's findings. So there are two expectations that we need to meet in this word problem. The first expectation is to help Sam to complete the table. We'll look at that first before we go to the next one. Alright, so how do we help Sam complete this? We need to understand the word problem. The word problem is talking about crickets. A cricket is an ant. And ants usually have 6 legs. Remember that. So a cricket has 6 legs. Therefore, for us to fill in the number of legs that Sam's crickets have, all we need to do is to reflect back on that number of legs each cricket has. For one cricket, there are 6 legs. So we fill in here as 6. But for 3 crickets, what can we do to find the answer? We can decide to go by successive addition, adding 6 and 6 and 6. That's going to give us the number 18. But instead of relying on our addition skill, which is of course correct, but will waste us a lot of time, we can choose to work by multiplication. Since each cricket has 6 legs, it simply means that all the crickets we are going to find will end up having the number of legs that are multiples of 6. So we can start multiplying the number of crickets we find by the number 6 to give us the total number of legs they have. Therefore, instead of saying 6 add 6 add 6, we can easily say 3 multiplied by 6. So all I will need to do to find my missing boxes is to multiply the numbers by 6. So to do that, 7 multiplied by 6 gives me the number 42. 11 times 6 is 66. 20 times 6, I can just go with 2 times 6, that gives me 12, and I add a 0. 8 times 6 will give me 48, and I bring down the double zeros. It gives me 4,800 legs. I have ended up solving the first requirement that says help Sam to complete his table. The next requirement that we need to fulfill here is to write a rule for Sam's finding. Now, a rule is more like an operation that guides a particular mathematical process, an operation that guides a calculation. From what we have seen so far in Sam's table, all we needed to do to find the number of legs that are possessed by the number of crickets he has found was to multiply the number of crickets by 6. So we can say the number of crickets here are the inputs using our one-step function machine. So we can decide to fill it in this way. Write your input, write your process. Your process, remember, is the same thing as your operation. And then the third level is your output, which is obviously going to be the rule we are looking for. So in the first case, the number of crickets, let's assume, this is an assumption. Remember, this is algebra, we make use of symbols and letters. So let's assume that the number of crickets, I'll just write number of C, okay? Number of crickets, let it be X this time around. The operation we are working with, we can borrow the operation here. We are multiplying by 6. So our center of operation is multiplied by 6. And if we multiply x by 6 algebraically, this is going to give us an output of 6x, which forms our rule. So we can easily say that the rule for Sam's finding is 6x. If you write it this way, you'll be very correct. If you also write it as 6 multiplied by n, where n means number of crickets found, it's also correct. Whichever way you do it is correct in any of these two ways. I hope by this explanation you've been able to get a clearer understanding of how to find a rule when you are dealing with one-step function machine. Let us look at two-step function machine and see how to solve problems relating to that as well. Thank you for watching.